Alright guys, I hope you're ready to put it all together. We've been learning about slopes of lines. Now we're going to be doing the slopes of parallel and perpendicular lines. That is the sound of your mind blowing. Alright, today's objective is students to be able to determine the line if two lines are parallel, perpendicular, or neither. That's it. Can you do that? Can you see if they're parallel, perpendicular, or not even either of those? So first let's review what parallel lines are. We've heard these words. I just want to give a formal definition. Parallel lines are two lines that never intersect. Okay? They don't. They'll never happen. They just go on and on forever, never intersecting. And they are also equal distance apart. This distance is always the same. The distance apart is always the same. Alright? Okay. Perpendicular lines are two lines that intersect to form 90-degree angles. Alright, so if you look here, we have two lines intersecting, and guess what? They create 90-degree angles. And that's what those little boxes mean. We got 90 degrees here and 90 degrees here. Okay, so let's start with the basics. Let's just look at these lines and say if they are parallel, perpendicular, or neither. Now these two, if you look, they both look like these can go on forever and ever and ever and never intersect. I would say that these are, in fact, parallel. Right? Those look parallel to me. Alright, they both have the same kind of direction. Nothing's changed there. Now these, what are these? Well, they're definitely not parallel because they're intersecting. And is this a 90-degree angle right here? No, it looks like to be an obtuse angle. So these are actually neither. Now what you call neither, here's a little vocab for you. Another way to say that is skew. These are skew lines. Alright? Just two ways to call it, neither or skew. Over here, look at this. We have two lines and they've got all these boxes around them. What are these boxes signifying? Well, that these are 90-degree angles. And since these are two lines intersecting to create 90-degree angles, this would be perpendicular lines. Alright? And these two, well, they're intersecting, so they're not parallel. And I'm looking at this. That looks, once again, obtuse. This looks acute. Those aren't 90-degree angles, so these are neither. Or once again, you could just call them skew. All right? Whatever works for you. Whatever floats your boat. Okay, so let's look at these lines on the coordinate plane and see if we can figure anything out. All right, something about the slopes of parallel lines, if we can figure out a principle just using our eyes. Well, let's go for it. I think the first thing to do is let's look at the slopes. Let's find the slope of Pn, or Np, and Lm. So the first slope, well, we're going to count up. So it's rise over run. So it's 1, 2, 3, 4, 5. Okay, and I see this point right here. And it's over 1, 2. So the slope of Np is 5 over 2. Let's go for the next one. I'm going to go up to this point, okay? So it's 1, 2, 3, 4, 5, and over 2. And look at that. It's 5 over 2. Now this, can we see something about these slopes, right, that maybe we could say about all parallel lines? Well, they look the same, right? So if you ever have two parallel lines, the slopes of them will always be the same. So parallel lines have the same slope. And that makes sense because if you have the same slope, then you're never going to intersect because you're both going up by the same amount. Yada yada. Oh, okay, sorry, I had to cut there. Almost died. I'm okay though. Alright, so let's see if we can find out some principle for the slopes of perpendicular lines. Let's look at NP, and then we'll look at the slope of QR and see if we can come up with something. So we'll start with NP, and if we're going to do rise over run, we're going to go down here. So it's 1, 2, 3, down 3. So it's negative 3, and over 1, 2, 3, 4, 5. So negative 3 over 5, that's our slope of NP. Now let's try QR now. Let's find the slope here. So it's up 1, 2, 3, 4, 5. And I'm going to try to go to this point right here. And it's over 1, 2, 3. So that was 5 over 3. Now if you look at these, they have things in common, but they're definitely different. And if I were to say what the difference is, they seem to be flipped over. This is 3 over 5, this is 5 over 3, and one seems to be negative. And yes, that is the kind of rule for perpendicular lines. Okay? Perpendicular lines have opposites, all right, opposite. Another way to say that is inverse. That's our math term for opposite. If opposites reciprocal slopes. And a reciprocal is just when you flip it. So just to give you a little language there, a reciprocal is when you flip a fraction. So this is the opposite, this is negative, this is positive, and they're the reciprocals because they flipped over. All right, we got it. So let's see if we could state the parallel and perpendicular slope for all of these lines. So for WX, the slope is 1/2. What would be the slope of the parallel line? It would be 1/2 too. Now what would be the perpendicular slope? Well, that's the opposite reciprocal, so we're going to turn it negative, and then we're going to flip it over. So 1/2 becomes 2/1. All right, and the easy way to write that, -2 divided by 1 is just -2. So that would be our perpendicular slope. And you know what, just because it's good math, let's write our m equals in there, okay? M equals. M means slope. This one, our slope of EF is -3/4, while our parallel slope, once again, it's just -3/4. And our perpendicular slope is the opposite. So since this is negative, our slope is EF is already negative, it's going to become positive. So our slope is going to be positive, and we're going to flip it over, the reciprocal, 4/3. Finally, the slope of PQ is 5. So the slope of PQ, the parallel line, will be 5. And here's a little tip for you. When we want to find the reciprocal, just put a 1 over there, because 5 is the same thing as 5/1. So to find the perpendicular line, it's going to be the opposite, so it's going to be negative, reciprocal, which is 1/5. And that is how it is done. So like I said, if you have a whole number, just pop a 1 under there. That'll tell you that's a good way to find the reciprocal. All right. For the second part of this, we want to determine if the following slopes are parallel, perpendicular, or neither. I should say are. Okay? So let's look at the first two slopes. We have M1, and remember that little, when they're small like this, that just means the first one and the second one. So our first slope is 7, and our second one is -1/7. Now, are these parallel, perpendicular, neither? Well, like I said before, we got to put a 1 underneath there, right? That'll help us with this. So is this the negative, the opposite, reciprocal? Well, it is the opposite, and it is the reciprocal, so these two slopes would be perpendicular. Let's take a look at these two. Slope 1 is 2/3. Slope 2 is -2/3. Are these parallel, perpendicular, or neither? Well, they're not the same because one's positive, one's negative. And they're not negative reciprocals. It's just negative, but it's not the reciprocals. So this would be neither. And finally, we have our last one, M1 and M2. And our first slope is 4/3, and the second one is 3/4. So these parallel, perpendicular, neither. Well, they're not the same, so they can't be parallel. This one, they're not opposites of each other because they're both positive, but they are reciprocals. But since they're not opposites, they can't be perpendicular, so parallel and perpendicular out, and this is just neither again. Well, look at that. All right, so finally, you want to be able to see if two lines are parallel, perpendicular, neither using points and using equations, if you had two equations. The first one we're going to do is determine whether the slopes of CD and EF are parallel, perpendicular, neither. And all we're given is points. So I want to see if these are parallel, perpendicular, or neither. Now, how am I going to do that? I have two lines. I have line CD, all right, and I have line EF. Just to start, so we get a visual on this, let's just graph it and see what it looks like. So C is -1, okay, -3, so that goes over here, and 1, 1. And D is 1, 1. That's over here. That's our first line. And let's draw a little line through that, okay? Got it. Oh, sorry, my line disappeared. And that line's right here. Okay, looks good. Now our second one is -1, 1. So let's put that point on. We got -1, 1, which is right here. And 0, 3, which is right here. And so let's put that on. Okay. So we're getting a sense of what these look like. Now let's just label it. So this was point C, this was point D, this is point E, and this is point F. So we got CD and EF. Those are our two lines. Now if you look at them, this goes back to our first part of the lesson. What do these even look like? My guess, based on what they look like, is parallel, right? We can guess that these two are parallel, just based on our graphing. But we could also use, if we didn't have a graph in front of us, the slope formula to find both the slopes and then confirm if they're the same. So let's do that. Let's use the slope formula to check if these are in fact the same slopes. So as you remember, we're going to do x1, y1. We're going to start by just labeling these. x1, y1, x2, y2. We're going to do it again over here, x1, y1, x2, y2. Those are two lines. Alright, so it's y2 minus y1, so it's going to be 1 minus negative 3. And on the bottom, it's x2 minus x1, which is 1 minus negative 1. We put this in our calculator, and we get 4 over 2, which should just give you 2. Alright, our slope of this one's 2, and if you even look at it, is it 2? Well, I rise. Well, we'll do that in a second. Now our second one, our y2 is 3, our y1 is 1, and our x2 is 0, and our x1 is negative 1. So we put this in the calculator, and you should get 2 over 1, which 2 divided by 1 is just 2. And sure enough, the slopes are the same, and look at that. They are, in fact, parallel. So that confirms it. You could, and if the slope formula didn't work for you, you could even count the slopes and see if the slopes are the same. However you want to do it, that's up to you. So let's try a different one. We're going to determine if these two lines are parallel, perpendicular, neither. So we have two different lines. We have this line, y equals 1/3 x plus 2, and this line, y equals 1/3 x minus 3. Well, let's use our knowledge. We're going to put everything together. Let's graph these two lines, look at them, and then we can confirm what their slopes are. Sorry, let me start with this. Let's find the slopes first. So the slope of this one, the m is 1/3. Alright? And the slope of this one, well, look at that. It's 1/3 again. So if we look at the two slopes, they're the same, so we know these two lines are parallel. Easy. Now, once again, you never know, so it's always good to graph, just to check, just to see if you're absolutely right about that. So let's look and see if they even look parallel. So we'll start by graphing this one, and remember, you start with your y-intercept, which is at 2, and our slope, at 2, and our slope is up 1 over 3, and that's our second point. And we'll graph that out, and that's what that one looks like. Alright, not perfect, but let's adjust it just a little. Good. Now let's do our next slope. The next one is, it starts at negative 3, so 1, 2, 3, negative 3 over here. And once again, it goes up 1 over 3. Done. And let's graph this guy. And if you look at these two lines, sure enough, they do look parallel. And so it confirms what we thought. If they have the same slope, they are parallel. Alright, final problem. Once again, we're given two lines. We want to find out if they're parallel, perpendicular, or neither. And once again, this could be called skew. Whoa. Skew. Well, the first one, we have to find, to do this, we need to find the slopes of both of them. And to do that, both of them need to be in y equals mx plus b form, or slope-intercept form. And the first one's okay. This is already in y equals mx plus b form. So we're just going to write the slope down, and this is negative 3 over 2. Now I look at the second one, and it's not already in y equals mx plus b form because there's this 3 in front of the y. So we're going to have to, once again, draw the line down and divide everything out. So divide by 3, divide by 3, and divide by 3. When we do that, we get y equals 2/3 x. 2 divided by 3 is just 2/3, plus 3 divided by 3 is 1. Well, let's identify the slope now. We figured out, we put it to y equals mx plus b. Our slope is just what's in front of x, so that's the 2/3. So our slope for this one is 2/3. So if I'm looking at these two slopes, this one's negative 3 over 2, this is 2 over 3. Do I know if these parallel, perpendicular, neither? Well, looking at these, I can tell that since this is negative 3 over 2 and this is 2/3, it is opposites and reciprocals. So these would be perpendicular, opposite reciprocals. And just in case you don't believe me, it's always good to practice by graphing it. Now, I don't want to take up any more of your time, so I want you to graph this on your own. Yes, I'm going to check to see if you did it, and see if they do even look perpendicular to you. All right, so start by graphing this one, then graph this one. Look at them, see if they're perpendicular. I might have lied to you. You got to check me. All right, guys, so remember, teachers sometimes lie. No, wait, they don't. They actually don't lie. We don't do that. Or maybe we do. Am I lying? Have a good day.